Welcome to Quanakantog. This is a classic barrier beach of southern Rhode Island, formed many thousands of years ago after the glaciers of the Ice Age receded back up to the headlands down here, which is called the Charlestown Moraine. Each one of these areas, there were headlands, one being here in Charlestown Beach, and one over behind me is the Quanakantog headlands, and they kind of were projections that came out as the glaciers receded. In each one of the coastal ponds, which is behind us, were actually an embayment of part of the ocean. Now, over time, the barriers, the sand movement started to build up sandbars and so forth that separated the coastal lagoons or salt ponds from the beach face, forming what we call a barrier beach. Now, the actual beach is formed by two forces. The most important force, of course, is the water and the ocean. And the action of the waves have carried energy, and as the waves, which go, far from the ocean, come up to the shore, that wave action starts to scuff up the bottom, picks up the sand in suspension, and deposits it on the shore. And this process is going on, of course, for thousands of years. If you look at the water's edge, you can see kind of the tan color, which is actually the sand that's being deposited. And of course, you got to think about this in terms of thousands and thousands of years of deposition. In the summertime, we have, as you see today, very low energy waves that tends to deposit the sand on the beach. And this newly deposited sand piles up and is what we call the berm, B-E-R-M. And that berm is really where people put their beach towels and enjoy the beach. Now, in the wintertime, we have more severe storms, higher energy waves, and what happens here is that the high energy waves tend to erode the beach. That's why we have such beach erosion during the winter storms. So we have the buildup of sand in the summer, which we call a summer beach, which is characterized by having a wide and very gently sloped beach. In the wintertime, with the amount of beach erosion that occurs, we have a narrow and very steep beach. And this is when we start to see real noticeable loss of beach face. Now, so we have the beach that builds up in the summer and recedes basically in the winter. Now, the water doesn't necessarily come perpendicular to the beach. Because of our orientation here in southern Rhode Island, our beaches are pretty much facing east and west. And so, in that plus the Earth's rotation, there is a general movement of sand from west to east, and we call that longshore drift. So the sand is constantly moving to the east. So when we have areas that are scoffed up, like for example, the Quanakantog headlands over here, you see is rock. And the people have built rock walls in front to protect their yards, but what happens is it doesn't collect the sand. So the sand bounces off and is deposited in other places. This is why today's regulations do not allow for rock formations on the beach. What is a preferred area, of course, is what we have here, is a barrier beach that is able to move as conditions change. Now, as we are experiencing a rise in sea level, these beaches are also getting thinner, and even though you can't see it, they're migrating slightly to the north. So when you have a rock situation like this, it's just going to cause more eddies and currents and worse erosion there. Where in a natural setting like we have here, the beach has an ability to move and to migrate. So even though the beach, in my lifetime, this beach is probably about 75 feet shorter, less wide than it was when I was a child. Okay, well, this is Fresh Pond Rock. It's probably one of the biggest rocks in the area, and pretty much stood up in dry land, and it was quite a landmark. In World War II, when the shore patrols were out patrolling the beaches and the blackouts were occurring to protect our shores, the shore patrol was afraid they couldn't see any enemy soldiers hiding behind the rock, so they blew it up with dynamite. And that's why this rock is so jagged on the top. Actually, where I'm standing is the top of the rock. It's buried in sand right now. But in a really low tide, after some beach erosion, it's exposed. And this rock formation, of course, goes way out. That's a very, very popular fishing spot. That's why Quanticontog has the name of Land of the Blackfish, because there's tautog later in the summer, and also striped bass in abundance in this area. Back when I was a kid, we used to go spearfishing down here. Now let's move out up the beach a little bit. And the other factor that it comes into play, let's walk up here. The other factor, we have the factor of the water, we also have the factor of the wind. And as you can see here, the sand is very dry, very fine, and almost like desert-like conditions. So when we have a good strong wind, the wind blows the wind-blown sand. And what happens, as you can see, is the beach grasses trap that wind-blown sand. So it tends to pile up. Now, even if you look really closely at each one of these clumps of grass, you can see actually a little mound of the sand. Well, you think about this in terms of many years of deposition and collecting the wind-blown sand, and then you end up with what we call a sand dune. And this is the sand dune. And the sand dune is vitally important here for several reasons. First and foremost, it's a barrier for flood protection, and it's also, because it's a sand material, it's flexible. So it can be sacrificial to a certain extent in a storm, but also build up. At the same time, this is a supply of sand. So after a storm, a lot of the sand that's collected here can replenish the beach as well. So the most important part of this is our beach grass. And this is American beach grass. And all of the grasses that you find along the barrier beach are adapted for growing in these arid conditions. I mean, basically, a beach is almost like a desert-like condition. So every one of the plants that grows here has a waxy coating on the outside, which holds the moisture in. So when we do have rain, it will secure that water and hold it so that the plants will survive even in the most drying conditions. American beach grass is our first line of defense here. One of the things that makes beach grass important, first of all, to catch the wind-blown sand, but also they have a root system. In fact, this is an example of one of the roots right here. These are called rhizome roots. And every plant is connected by a series of these rhizome roots to form a network. So not only does the beach grass collect the wind-blown sand, but the root system holds the dune in place. So the most important factor here is the ability of the grasses in the barrier beach system to hold and build the dune. Now, after a severe storm that we had after the, well, it was a hurricane followed by the blizzard of '78, this beach was very, very badly eroded to the extent that where we were standing was probably below, we were standing about 12 feet higher than the beach was at that particular storm. Well, with concentration of putting in the snow fence, and the snow fence, we try to call it dune fencing now, it's more politically correct. That will catch the windblown sand, and it will stabilize the sand movement, and as a result, it will tend to pile up. And that gives the beach grass a chance to recolonize. And this is a really good example of how the grass has recolonized even seaward of where the dune area was. And eventually this, and you can actually see the elevation now change, this will be the newest part of the dune that will be building up. So this is a really good sign, and things are doing well. Of course, this is a one storm away situation. We've been working, personally I've been working on this for over 40 years to build this beach up in the condition it's in, weather permitting. But if we have a severe storm, we have a Hurricane Carol or a 1938 hurricane, we start from scratch. This would all be gone. But during a normal condition, in fact, even a storm as bad as Sandy was, we had a few washover points, but nothing really significant. Our dunes held, which is what they were supposed to do. So along the dune here, this area, now we have a high energy area, so there's not a whole lot of vegetation going on here. As we get into the dune area, and this is called the foredune, we have less activity and we have more stability, so the grasses are starting to grow. And the grasses are very flexible. They'll die out in the wintertime and come back in the summer. So let's go back a little bit, and I'll show you a little bit about the succession of the plant life that goes on in the barrier beach. Okay, this will give you a little bit more of a lesson on succession. Now we have the grassy area on the front or the foredune, which you see here, and it's developing very, very nicely. As we get back further in the dune, we have less wind activity and more stability in the soil. As a result, we're having more of a species diversity. We have seaside goldenrod, which in another month will have a beautiful yellow flower on it. We have the beach pea. The beach pea is coming up through here. It's actually gone by, but they have a purple flower, and then they have a little pea pod. And of course the pea pods and a lot of these things provide for food for wildlife as well. Now as we go a little bit further back, you will start to see shrubbery. Now there's a beach rose over there, and that has a pink or a white flower, and as you can see, it has the fruit, which we call a rose hip. Now people make jelly and tea out of rose hip, but most importantly, it's a food source. And one of the things that's vitally important for this area is that this whole south coast of Rhode Island is considered the Atlantic flyway. And our barrier beach communities are a resting point for migratory waterfowl. So on their trip from the south north, they will stop here and rest. You have berries to eat, you have shelter that they can hide and rest in. It's not necessarily a major breeding ground, but it's certainly important in terms of the stopover. So the Atlantic flyway, and that's one of the main reasons why so many of our barrier beaches, particularly in the Integrat Conservation Area and the Quanticontog Beach Conservation Area, are maintained as bird habitat and wildlife habitat because they have a great value. Beyond that, we also have, you can see, bayberry. And again, bayberry has, you can start to see the little gray berries there. Again, food for wildlife. All of these plants have that waxy coating on them, so they survive very, very well in the arid conditions of the beach. So we've gone from grasses now to shrubs. Now, the pine trees behind you are not native. They are Japanese black pines, and we planted them in the 70s, again, as a windbreak and also to hold the dunes. A little bit controversial by today's standards. They are non-native. They have served us very well in certain areas. Other areas, they've had a blight that has killed them. As you can see, ours are doing very, very well and continue to support the beach. But like I said, it can be a little bit controversial. So we go from there up to the wooded area and the upland area. So this is the succession along the barrier. Now, if we were down at the pond area, that succession would change in reverse. You'd go from the grasses to the shrubs to the trees, back to the shrubs, back to the grasses, and then to the salt marshes of the barrier beach.